Hi, this is Emma Dowd. I'm the Assistant Director of the IUSM Proteomics Core, and this module of the Bioinformatics course will be covering Scaffold PTM analysis and visualization. So I hope you've already listened to the Scaffold data analysis and visualization. This is kind of a next level sort of data analysis processing program. So again, this is by Proteome Discover software, or Proteome software, excuse me. And Scaffold PTM is a different way of viewing and analyzing PTM localization and confidence. So again, this tool automates calculation of the A-score. I believe this was discussed a couple of lectures ago, which gives you a probability of how likely the in many examples, phosphorylation is confidently localized. And you can click here. Again, you can use Scaffold PTM in viewer mode if you do not have a license. So to begin with the data analysis from Scaffold PTM, you need to load a results file. So this can be an output from a software like Proteome Discover that does do some phosphorylation localization, or a workflow software like Scaffold, which is an SQML file. So anything that's been searched and some of the MS ions identified, because essentially what Scaffold PTM does is look for those characteristic diagnostic ions that will allow confident localization of specific PTMs. So this is, again, a nice schematic of understanding how we do our data processing just with our LCMS system, which generates raw files. And you can use systems such as Peaks, which we'll talk about in the next module, or any database search engine to get some results, which can be further filtered for FDR cutoffs, and then load this into Scaffold PTM. So the A-score. So this is the key component that's within Scaffold PTM, and there's several different proteomics workflows that actually calculate the A-score. So in Proteome Discover, I mentioned this IMP PTM RS, and it is a similar but different algorithm that gives you a localization probability score. So you don't need to use Scaffold PTM to get a localization probability. I can give you that directly from Proteome Discover, but it is nice to have a viewer with capabilities such as Scaffold PTM. And the A-score is a really classic way. It's a probabilistic approach that is looking for these diagnostic ions. So traditionally, you would be manually walking through, you would find your precursors that had potential PTMs with delta M over Z's from an unmodified peptide. And what you would do is you would look and see what fragments are present and whether that would cover the site. To have a diagnostic ion, you need to have essentially enough confidence before and after where the PTM is in terms of the number of fragment ions present. This is developed by the Gigi Lab at Harvard Medical School. And here's a couple of papers that you can read about if you want to reference the algorithm a little bit more. So here again is what is this diagnostic ion? So again, you have some PTM that could be on any ST or Y residue. So for example, these two peptides would have the same precursor M over Z. But to confidently identify whether it's on the threonine or the serine, you would need some of these B or Y ions that are located between the two residues. If you don't have a fragment here, you can't determine which amino acid contains the modification. So in this example, the presence of the Y3, 4, and 5 ions, or 8, 9, and 10 B ions will give you that determination. And so essentially what Scaffold PTM is doing is going through, looking for the presence of these diagnostic ions, and then giving it a score as to how confidently localized and identified any PTM is. So this is the Scaffold summary view. It allows, again, easy visualization. I think this is one of the greatest things about the Scaffold type softwares is it's very easy for you to kind of just click through. And this is similar to Scaffold, and then you can filter the summary level at MS, minimum localization percentage likelihood, which modifications are visible, the total number of modification sites, any number of filters are present, and you can kind of walk through individual proteins. Again, organizing this is analogous to the Scaffold software itself, where you have an organization or loading setting of your search data. This view, which is a PTM list, looking at all the different modifications that you had included in your search, and then the protein view. So, for example, if you select a protein that has a number of phosphorylations, this is the view. And again, it's analogous to what you would see in Scaffold, but again, this is focused specifically for PTM modifications. So in Scaffold, where you would have the highlighted residues showing sequence coverage, this is really emphasizing which residues are modified and how confidently they are modified. So in the single sample, you can see there's a number of peptides that have no phosphorylations. There's a number of peptides that have multiple phosphorylations. In this case, this is a peptide with a less than confident phosphorylation. So I've just clicked one example peptide. So it's a little bit hard to see which peptide was clicked. And that's just a kind of a consequence of doing this in slide form instead of live. But it is, I'm not sure which one it is actually, but I chose one with a 100% localization probability and an A score of over 100. So you'll see that the A score and the localization probability kind of go hand in hand. So as the A score increases, the localization probability is becoming more confident. And you can see this is, again, the spectrum and the fragmentation pattern. Really nice visual if you're setting up for a paper, something like that. And you can see that the reason this A score is 100% is that you have enough combined B and Y ions to specifically say that this serine is the one that's phosphorylated. So it helps that there are not a lot of other serines or threonines or tyrosines in the sequence that could be phosphorylated, but you have enough coverage of the other serines to say that they don't have a modification on them, whereas this serine does. So in contrast, I did find one with a really low localization probability. It has an A score of 0. And so when you click on that, you can see the sequence score is high because it's the peptide exists and it has the modification. However, when you look down here in the spectrum and A score, you have really low abundance fragment ions. So there's a lot of background. And you cannot confidently say where the phosphorylation occurs, because if you look at the B and Y ions, they're not covering this whole middle section of the protein. And if you look where the Y ions run out and where the B ions run out, you're missing about 3 different sites that could be phosphorylated. And that adds up to 33%. So it's completely unlocalized between 3 serines, and that's just a consequence of it happens often in phosphorylation data because phospho groups are negatively charged, and you have the challenge of when you fragment something that has a negative charge on it, you may not see the ion in the mass spectrometer. Just wanted to go over another high confidence example and kind of give you a zoom in of how these the low confidence versus highly identified high confidence ions are. And that's Scaffold PTM. And so it can be a really useful tool for data visualization.